Okay, today is day 3 of chapter 19, 19.1, day 3. And again, it's about vectors, and we've learned a lot about vectors. Do you get that I could say that that vector is vector A and this vector is vector B? The one that's nicer, that's like easier to read, is the one that's at the origin. But the vector could be over there. Now the ones that are at the origin, we've been struggling to describe what direction it goes in. And the thing is, if you put it as a vector that starts at the origin, it's really easy to describe that it goes to the right 4 and up 3. And so you could write that vector then as 4 in the x direction and 3 in the y direction. Now, if I used x and y, though, do you get that that would be the rectangular number system? And we are doing vectors right now, which has its own system. Instead of x and y being this, x and y, for vectors, it's I and j. And I think that I is kind of an unfortunate choice because we're coming off fairly recently a chapter called Complex Numbers where i's were what? Imaginaries. They were complex numbers, yes. They were part of the complex number system. This I, these are not imaginaries. It's just they chose I, j, and then when it's three-dimensional, as you can see in the room, you can't see on the video, but I have a set up 3D system. It's in rectangular, we call it x, y, and z. Take a wild guess what we're going to call it in vectors. I, j, k. Yep. And I goes in this direction. That's positive. Okay, that's over this way. I's this way. J is the up and down. And the k is, I can't show it on the board, but it's out towards you. It's like if this point were to come out towards you and extend out, towards your face, that's the k direction. So again, something you can't see on the video, but this, I have a big pink ball here that is at a point in space that we can describe in 3 numbers. How far over to the right, which is like x, how far y, which is like up and down, and how far z, which is like from here towards you, how far is it? And in feet, I would say this one, would you guys agree it's about 2 feet to the right of the origin there? Okay. And then it's down about a foot, and then it's towards you about a foot. We don't say x, y, z, though, because we're using vectors. So it's I, j, k. Would you please write the equation for the vector that would go from the origin to that spot? So if I had a ruler to represent my vector, it starts at 0, 0, and it's going to over 2, down 1, and then 1 out towards you. Please write what that pink ball in my room would be at. Okay, you should have said 2 to the right, which is 2 what? I plus, what's next? 1 down, how do I do that? Minus 1 in the up-down direction, which is the what? J. And then the last thing is 1 towards you, which is positive, K. And if I call this vector P, because it's a pink ball at the end of it, vector P would be at that. Now this is important to get. It starts at the origin just because it's easier that way. Do you get if I wanted to, I could make another one that's in the same direction and has the same magnitude by keeping it the same length and just moving it down a little bit? Do you get this one still at the same direction and has the same magnitude? Even if I move it over here, if I'm keeping it at the same angle, the same direction, and I keep it the same length, then that's also, again, I'm probably off a little bit, but that's also the same vector. So When you have a vector that's not at the origin, it's best to just put it at the origin to make your life easier to tell what it is. Like this little vector. It's going to be really hard to describe it. Where this one I could describe easy, because I could say this guy is just at over 4 and up 3, so I could say it's 4I plus 3j. That's a good description for that vector. Okay? But this guy is way harder to describe because he's not at the origin. So if I put him at the origin, do you get it'd be really easy to describe this? It's at -2, +2. -2I plus +2j. Okay. Now, you might feel like, but you changed it because you moved it. Well, it's the same exact resultant. It's the same exact vector, whether it's here, or whether it's down here, or whether it's over here, or whether it's over there. It's the same distance and magnitude, or sorry, magnitude and direction. Magnitude and direction are the same, even if it's over here. All right, so I'd like to give you a couple other ones. Here's 2 vectors that aren't at the origin, but still tell me what their names are in I, J. And since they're not three-dimensional, we don't have to worry about K. Just I and J. Well, in your mind, you could imagine that you moved it over to the origin like this, but you don't need to. You can just think about it and bring the origin to it. And in your head, just kind of like act like, well, that's kind of like the origin now. And do you get that this one would be 3, 4 to the right and up 3? So 4I plus 3j. Raise your hand if you had that one right. Okay, cool. So it doesn't matter if it's sitting over there or if it's moved to the origin. It's still 4I plus 3j. And this guy, imagine that you move it to the origin or bring the origin to it. And do you get his would be -2, 2, except wait a minute, you just took out the I and the j. -2I plus 2j. There is a shortcut way to write these, and we do it a lot. In fact, most of the test is going to be written this way. This guy, instead of writing this, we will write it shortcut as -2, 2. We put them over each other so they don't look like points. But I've actually seen videos where some teachers put them in, instead of having like a point like this, because that definitely looks like a point, okay? They'll make it pointy on the ends because they're vectors. But there's a lot of ways to do it, but we usually write them as what's called a column vector. You write it up and down, and then you say it's -2, 2. All right, I'm going to give you one more like this. I'm just going to draw one on here. Let's say I had this vector. Write it in both column vector form, that's the clean, easy one in parentheses, also write it with an I and a J. That's called position vector form. This way, position vector. This way, column vector. Make it for this red little arrow right there. Write it down, and I ask you to compare it to the kid next to you in a moment. I'm going to pause while I pair you with somebody. Okay, so for this red one, if I were to bring it to the origin, it's an easy way to do it. It's 1 to the right and up 2. So 1I plus 2j. Or you could have written it as a column vector, 1, 2. Raise your hand if you had that one right. Good. Okay. Now, let's say I wanted to figure out how to get this 4I plus 3j answer. I'm doing vector A right now. This guy. I want to get that from his points. He started here at 1, 2, 3, 4, -5, comma 1. And he ended, could be a she, whatever, ended at -1, 4. How could those 2 points have gotten you the 4 and 3 that we ended up with? What could you have done with this point and this point that could have gotten you that without having to move it? Talk to your partner and see if you figure it out, tell them. Okay, and I think a lot of you caught that. It was take the head end, the 4 minus the tail end, the 1. And for my y's, I did 4 minus 1 gets me my 3. And the negative 1 here, and the negative 5, what's negative 1 minus negative 5? It's like negative 1 plus 5, which is giving us our positive 4. So yeah, you can just subtract the head end minus the tail end if you want to. All right, so if that's true, then what if I have a head end starting here at 2, 1, and I have a tail end there at 1, 2, 3, 4, 5, 6, 2? Isn't it feel a little bit like slope? Kind of you're subtracting a couple things. It's not exactly like slope though, because otherwise we would just get a slope of one single number. Our answer on this isn't a single number. It's a column vector. Okay, so give me the answer for the one that starts here and ends here. I'll pause while you give that a try. Okay, so to get the x's, you'd go 6 minus the 2 gives you 4. 2 minus the 1 gives you 1. 4, 1. And also, if you just think about it, doesn't it go over 4 and up 1? So if I moved it to the origin, it would be really easy to see it was 4, 1. Or 4i plus 1j. All right, what if it had 3 dimensions? All you'd have to do is throw on a third number in the column. So let's say it was this, 2, 1, negative 3. I'd like you to envision what that would look like in 3D. It has an x and a y, and then the z-axis, or the ijk, the k-axis comes out towards you off the page. Oh, I heard somebody say it perfectly. Over 2, up 1, and then at you, straight at you, or in this case, it's negative at you, which is away from you, 3. Now, that's just a dot, though. Do you get that the vector is at 0, 0 to that point that is away from us? All right, now, just so you can have a way to do this, some of you are better than others at the art. If you want to do it really fast, make a rectangle or square, make another square, connect the corners. Okay, then I got 3D. Okay, and now, do you get I can run my x and y axis? Like, I can call that the y-axis, I can call that the x-axis, and the one that's coming out towards me here, that can be the z-axis that's running away from us. So anything that's in the cube, if I call this the I, this the j, and this the k-axis, anything that's in the cube is all positive numbers then? All right. So if you try to envision 2, 1, negative 3, that would go like this. Over 2, up 1, but negative 3, that goes back 3 notches on this. And my ray goes from the origin backwards. I know for some of you are not so awesome at seeing things in 3D. My picture isn't awesome there either. But that's a way to do 2 to the right, up 1, and then back 3 spots away from us. All right. So It's a lot easier in the room where I have this big pink point. Okay? So I'd like to just show you how to write these points with one more. Mason, catch this. Now hold it up. That dot that he's holding, imagine that's the point of a vector that's starting at 0, 0, and it's going to there. Do you get it as distance, which is magnitude in this case? Again, it's got a direction that it's going. You need magnitude and direction to make a vector. Okay? So keep it at try to keep it at a consistent place right there. Would everybody tell me what the column vector, what are the 3 numbers for that ball, and we're doing it in feet? What, comma, what, comma, what would be that ball, and therefore the vector that goes to that ball? We're going to say he's about 3 feet over. It's way under the line, right? So it's down at least, I'd say about down 1. If you had to add, just estimate it, and then I'll tell you pretty exactly how many feet back it is. All right, here's how many feet back it is. 3, 6, about 7 feet back. Maybe 8. You could argue it's 8. All right, so then, here it is. It's over 3, down 1, back towards you, which is positives, because it's coming towards you. 7, or did you guys use 8 or 7? How many have said 7? How many have said 8? Oh, that's pretty close. It's probably 7.5 feet. Anyway, I don't care. I'm going to go with 8. All right, so 3, -1, 8 should have been your answer. Raise your hand if you were close to that anyway. Okay, good. You can put your hand down. I know it gets painful after a while. Imagine being a painter, have your arms over your head the whole day. Anyway, all right, so if I wanted to add a couple vectors together, you don't have to overthink this. If I wanted to add this vector to another vector, and it was at 5, 0, +3, all you have to do is add the numbers together. It is that simple. Okay? So I'm going to prove to you that it's that simple by doing a simple one with these guys. Actually, I'm going to go back to these guys. If I wanted to add A plus B, all I got to do is, since I can do this, I can just grab this and move it over here. Do you get that my resultant looks like that? But wouldn't it be a lot easier if I moved it all to the origin and did that? All right. So again, if I wanted to, I could move this over here and this over here, and it'd be pretty easy to get my answer. Now I want you to just see how easy it would have been if I'd have just done it with numbers. Back to where positions where they were. What is this guy's description again in a column? What, comma, what? Well, 4, 3. You agree that guy's 4, 3? Okay, how about this guy? -2, 2. You get that? Okay, what do you think it's going to be when I add 4, 3 plus -2, 2? Just looking at the numbers, doesn't it seem like you're going to go 4 plus -2 makes 2? And 3 plus the 2 makes 5? Well, let's draw it and see what happens. When I move this over here, and I move this up here, does 2, 5 work for our resultant? Here's our resultant. That green arrow has been described as over 2 and up 5, 2, 5. Yeah, so it's that simple. So don't overthink these. When they say you've got this vector and it's 2, 3, 7, and it's called A. And here's another one we're going to call B, and it's at -1, 3, 12. What if they say to add the vectors? You just go like this, and you add the top numbers, the middle numbers, and the bottom numbers. What if they say we're going to double this one, and then add this one? It's not that complicated. Why don't you and your partner try to figure out what you think the answer to that is? All right, so you're just going to go 2 times 2 is 4, minus the 1 makes 3. Raise your hand if you guys had 3 for your first spot. Okay, good. And then similarly for the next spot, let's call Dice of Destiny to see which group to call on here. Row 6, last spot. What you got? 2 times 3 is 6, plus 3 makes 9. You are correct. And then the last spot is row 2, last group. All right, 14 plus the 12, 26. That's all there is to it. Now, what is the answer? The answer is a vector that if you moved it to the origin, and I got to make x, y, and z, sometimes people do it this way, where the z-axis, does that feel a little bit like it's coming out towards you, that dotted line? Anyway, it's another way to do it. It goes over 3, up 9, up here, but then it has to come out towards you, which I can't just do on the board. It has to come out towards you 26, which is a lot, and then it's the vector that goes from 0, 0 out to this point I'm holding in front of the board. Okay, that's the answer to a vector that was doubled and then added to a different vector. All right, so let's look at the homework together. I'm going to pause like. Okay, here it is. And what did I do right away? I took position vectors and made them into column vectors because it's just so much easier. Okay, so I took this position vector and then made it into a column vector because now I don't have to worry about i's and j's and k's. And the first thing they want is 3b, so I take the b one, which is that guy, and I go 3 times it. So don't overthink these. It's just 3 times 4, 7, 5. That's all there is to it. All right, this next one's kind of set up, and again, I made these position vectors into column vectors, and then same thing with B, OB. That goes to there. And you're just doing the one vector minus 5 times the other vector. All right, that's the easy part. This is more of the exact same thing, it's just they give you the column vectors right off the bat, which is nicer. This one is saying if you had points at 2, negative 1, that's kind of like this little vector that would go to 2, negative 1. And then you ended up at 3, negative 2, that's this other spot over here, and that's kind of like a vector here. Do you get how you could get a vector that goes from this spot to that spot? And so it wouldn't be that hard to see that it goes 5 to the left and then up 3. So I've got that already. What's the point? It says find AB, but I want to know what were the position vectors that join the 2 points. In other words, what plus what gave you that answer? I'm giving you the answer because I think you could get it pretty easy. It goes 5 to the left and up 3. But what got added or subtracted, remember this, to get those? What plus or what minus what would have given you the negative 5, 3. All right. And then the last thing we're doing is, let me make sure. We're going up to number 8. Number 8 is the last one. You may skip 9 and the one after that. I can't remember what it's called, but this one skipped and the one after it is skipped. So just do up to number 8. Now I started you on number 8 by giving you an equation. It wants you to find values of A and B. Well, hint, I can get this equation for A, but do you get that it'll only be able to be solved in terms of I? So if I have to solve for 2 different things, I'm going to need more than one equation. I hope you can see where I got my first equation. It was just this times this minus this times this equaled that. Well, then there's a middle one that you can do. And then there's a third one, and then you'll have 3 equations. You're in an honors class. That's where you're going to have to step up a little bit and solve a system of 3 equations. It's the only really hard one that there is today. All right, so that's all we've got for new stuff for today.